So, arguably, autonomy is the biggest topic, not only in agricultural machine development, but in all on and off-road segments in use today. There's a ton of research and development and investment that's going into that. So there's a lot to talk about. But let's focus on ag. So where exactly are the major brands at with delivering an autonomous machine for your farm? Well, today I had a chance to speak to a couple of people in the know from two major brands, John Deere and AGCO. And I asked them about their autonomous development projects and where the status of the engineering is at their firms today. So first of all, you're going to hear from Margot Asherow. She's John Deere's, let me get this right, Program Delivery Manager for Autonomy. So I asked her, where is autonomy, what's the status of autonomy at John Deere these days? And we also talked about something that a lot of people might not consider, the spin-off benefits from autonomous research and development, those features that are already being put into today's line of machines that are making them smarter and more efficient than ever. Listen into our conversation.
So where's Deere at with autonomy right now? I know they introduced that tracked module at Agritechnica last year, which was not only autonomous, but electric drive, if I remember correctly. And, I remember seeing, what was it, back in, over 10 years ago, Deere had that little concept, kind of like a 5E size tractor that they had in the museum for a while in Moline there. So I know Deere's been tinkering or experimenting or R&Ding the idea for a long time. Where's it at right now?
Yeah, so I'd say, like you said, we've been on this journey for quite a while. I would say where you've seen some of the product launches along the way benefiting from that technology is in our guidance solutions. It's in our data solutions. We've learned a lot as tech has grown too, to actually enable this technology to be marketable and to be, to be built into a product that is sustainable and something that you can support long term and that farmers can actually use on their farms and in their fleets. And so, as technology has evolved, so have we. I think those early concepts, we learned a ton. But one of the biggest learnings that we had in those projects were that, we're not doing autonomy for the sake of autonomy. We're doing autonomy because it's one solution to customers' problems. And so, as we vet those types of solutions and that technology out, we're looking across the entire fleet to understand where technology best in autonomy specifically fits best in a customer's operation. There's a lot of opportunity in there, but you have to make it work within a farmer's operation. Managing an autonomous fleet shouldn't create more problems around, labor and supervision and understanding of how that machine is working and what it's going to do and all of those key components. And, what I think we've learned along the way in this journey is how important that is. And so if you look at something like the John Deere Operations Center, for instance, that gives us a platform that customers are already using on their farms. Allows us to use, common new practices and technology that customers are used to start enabling an autonomous fleet, if you will. So, where are we on the journey? We've got several. I can't wait till we can talk about those projects in the hopper. But what I would say is we've launched several products along the way that have benefited from that R&D. So if you look at the Exact Emerge planter being able to, precisely place a seed going 10 miles an hour, or the See and Spray products that we're working on now and now publicly available, our relationship with Blue River, for example, with machine learning, and then if you even look at the our combine advisor, within the harvesting platform, those are good examples where we've at least found a nice way to introduce that technology that makes sense on a customer's farm now, because that's what really matters. So while we've been R&Ding for a long time, we don't have an autonomous machine that's out there, fully autonomous and whatnot, a lot of those technologies have benefited from the autonomy journey along the way and will continue to do so.
So Deere's approach has been to incorporate autonomous aspects like the grain cart following technology and all of that, kind of similar to where the automotive world has been with park assist and all of that. Has doing that allowed you to really refine those products a lot more, but looking down the road to where they might be totally autonomous? Has that been a great part of an R&D for these concepts?
Yeah, absolutely. I mean, one of the things that we needed to learn along the way was how exactly customers would use this technology, what benefits they would see as they were, as they put these on the farm, and sometimes there's, with new technology, there's unintended consequences, and then there's sometimes unintended benefits that, that come up. And so, as we've been able to work and partner with farmers using our technology, and that's part of our R&D process along the way, is to actually put these, these new technologies, even before they're released as products, we work with our farmers, to use the technology, understand how it impacts their business overall, their farm overall, and really take those learnings into consideration. And, again, if we look at the projects that we're working on today in the R&D space, and again, I wish we could talk about them in a lot of detail, but we are absolutely taking everything we did 10 years ago and some of the learnings we had back then. A lot of them still apply today, and it's allowing us to move much faster than I think we would have been able to otherwise. And I would say that's actually true for even the released products that we have, that are not necessarily autonomous. We are taking that customer feedback and those learnings from the farm and actually incorporating it into our autonomy strategy as well. So, the biggest need is to solve the customer problems that they're facing today and not introduce new ones. We need to make this easy for farmers.
Well, you've heard Margot Asherle describe how working on autonomous machine projects at Deere has resulted in spin-off technologies that have been put directly into today's line of equipment that's available on dealers' lots now. The same is true at AGCO, and I spoke to that company's vice president of crop care of the crop care product line, Matt Rushing, about how spin-off technologies from their Xaver autonomous machine development project have benefited AGCO's current line of equipment.
Yeah, we've got several different things that we're focused on in several different form factors. Xaver being the primary robotics form factor that we're looking at for smart projects or smart programs. If you look across our whole portfolio, though, we're looking at making even the current form factors or even the current machines that we offer today much smarter. So ingraining some autonomy along with some intelligence allows us to continue to not focus just on robotics, but also improve the smart element of everything that we build.
So those features built into current equipment line are the result of autonomous research and development projects?
Absolutely. A lot of those things that we learn as we're developing autonomous solutions, we can integrate on current machines and provide that farmer with the additional benefits quicker than having to wait for him to adopt some type of a robot. So we learn a lot by developing these programs.
In talking with farmers, and we talked earlier about how some new features on the regular equipment are moving toward smarter technology for the machines. How have you found acceptance and uptake by buyers of today's line of equipment in terms of those more autonomous or more intelligent features?
I'd say it's the speed in which farmers are adopting these technologies continues to go faster, to get faster, and the technology to be adopted quicker. I think the reason why is a couple of things. Number one, I think the acceptance level of technology in most farmers' lives has started to accelerate, right? So not just around farming technology, but communications technology, systems that they use to help them make decisions, interactions with their peer groups and their decision support providers. All those things are helping them to adapt faster to any new technology that's emerging. When you look at technology that actually goes on equipment or is used when they're actually farming in the crop cycle, I think that the main reason they're adopting faster is they're understanding the benefits of using those technologies quicker. And I think that comes from the approach that companies like AGCO and Fendt are taking to educate farmers more about the ROI, not so much about the technology itself or trying to explain the specifications, but really focusing on how the technology is going to benefit them and pay back in real world examples on their farm. And I think that's what's helped them to speed up adoption and to accept new technologies faster.
A lot of the technology in the equipment, and even on Zaver, we're talking about control with regular iPad. Is keeping that sort of central iPad, iPhone device central to a lot of these technologies for familiarization or easy familiarization with the customers? Has that become really important in
Absolutely. Absolutely, it has. It's one of the things that they're used to using in their everyday lives, and even becoming more and more used to using when they're farming, right? So it's become kind of a decision user interface for them. And I think if you took the Zaver, for example, it uses a specific cloud designed for it. So the Fendt Zaver cloud, and it utilizes that cloud to receive commands and then to return their status and readiness back to the user interface that the farmer is using. The system's web-based and it's managed independently in the Zaver app on a smart device. So we continue to use the smart device as the user interface for the operator or the farmer. This means that the grower can, he can access the entire fleet through one user interface versus multiple ones, or having a unique device or user interface for those robots in the field or for his machines in the field. It's easily transferred onto, like I said, a tablet or an office PC. And we also are very focused on what we call the Fendt One user interface, the online user interface, or the cloud user interface. And that portal actually gives you access to not only your autonomous machines and the Zaver machines, but also your typical farm equipment as well. So you can have a mixed fleet. And when I say mixed fleet, not just that you can have multiple brands of equipment potentially, but you can also have multiple types, meaning robotic and traditional farm equipment, and monitor them all through one unique user interface. And that, again, makes it super intuitive for first-time users.
Well, in those two segments, you heard a bit about how the R&D around autonomous vehicle and machine development has led to spin-off technologies going straight into the current line of equipment offered by major brands. And Matt Rushing talked quite a bit about Zaver, the autonomous machine project that AGCO's Fendt brand has been working on for some time now. Pretty unique design. It's molded on the swarm concept of working a field, kind of like a swarm of insects. A bunch of very small machines are turned loose in a field to seed it. And although they're small, their speed isn't that great, but the number of them, the swarm, and the fact that they can work 24/7 certainly compensate for their slow pace through the field. I had a discussion with Matt about the development of that project and where it stands now.
Now, Zaver is pretty unique in terms of its design. Can you talk a bit about that?
Yeah, we've gone through a couple of different iterations of that design. So the latest generation comes with an integrated seed unit that was developed by Precision Planting. We've been leveraging the Precision Planting team's agronomy and agronomic expertise, and also their research capability, and combine that with the first generation technology that we developed for Zaver to complete kind of an integrated planting system that basically automates the row unit. So that's where we've been focused, is on automating the row unit on the planter. One thing you'll see is very different from the first generation, and very evident, very obvious in the next generation of the fence auger, is the design switch from 4 to 3 wheels. So the first generation had 4 wheels, the new generation has 3. We increased the wheel diameter to offer increased ground contact and to give ourselves some greater ground clearance as well. So it allows us to be a little bit higher and allows us to operate in more changing environments. We also changed it so that we could get better depth control, because, as you know, one of the things that are very, very important about planting is making sure that you're planting at the right depth. So that helps us to also manage that. You can really see the benefits of the 3-wheel design in the headlands when the machine turns. So one of the things that we've been able to improve is its ability to turn in a smaller space, so that we can maintain the right spacing between the rows. We've also added some wheel weights to the unit. That makes it quite a bit heavier while still optimizing the ground pressure, right? Because one of the things that you need when you're planting is a stable presence on the soil. So we've optimized that for different soil conditions, and fully ballasted, the machine now can reach a maximum total weight of about 550 pounds, which allows you to put the right pressure, not too much pressure to cause additional compaction, but the right pressure on the row unit. And if you look at it completely unweighted, it's about 330 pounds. We've also extended the seed capacity, or the seed tank capacity. We've made that about half a bushel, or 5 gallons. So that's enough for about 1.2 acres of planting at normal population settings. So we've made some significant improvements there to make it a little bit more usable in the planting application.
Has Xavier been in the field in any capacity here in North America in the R&D program?
Not in North America. We've mainly been running it close to our factory in Marktoberdorf, Germany. So there are some farms around Munich and around the Marktoberdorf area that we've had the units running in. Also in other places in Europe, on test farms and in other locations there, to get feedback from real-world farmers, but also close enough to where our R&D team can stay close to the unit and monitor its performance.
So in the big Fendt press conference from back in October, there was a suggestion by one of the senior executives there that it would soon be commercialized. Has there been any update on where that might stand?
Yeah, I think if we think about where it's going to become commercially available in the future, we're still kind of exploring what's the best time to offer the systems more commercially. Again, you're switching from a practice that is typically very dear and near to the farmer's heart, and that's planting, right? Planting is probably the most important application on the farm. If you don't get the seed planted right, nothing else matters. So there's got to be some time associated with adoption and understanding what the benefits are of the system and getting farmers to buy into that. So that's one of the things that we're currently exploring as we look at commercial availability. We're also going to be working with growers in different geographies, so not just Europe, but in other geographies around the world, to educate them on its benefits. I think that's a big stepping stone to get to more commercial viability and availability, is to get it out in front of farmers and educate them more on how it can help them.
Is there a timeline for that here in North America at all?
I don't want to speak to a timeline right now. That's a difficult one, because again, as you go through some of these next steps, we're going to learn more as we go. But we're looking to see what market makes the most sense for sure. Typically, planting is important in all markets, whether it be Europe, North America, or South America. So we're evaluating that as part of our commercial strategy approach.
So Xavier right now is set up. You were talking about a corn planter technology on it. I assume that can be adapted fairly easily to small grains.
Yeah, I think if you look at where we've started mainly in corn, and that's been a good place to start, especially with the expertise that we have in row crop planting, shared between AGCO and Precision Planting. But I think other crops traditionally planted by the row crop planter are also in scope. So if you think about things like sugar beets, sunflowers, and other commodities like that, crops that are highly singulated today are probably the best place to start. So that's where we've begun our journey.
While no one should be surprised the major brands are working on developing autonomous equipment, the self-driving machine prairie farmers are most likely to recognize is DOT, the U-shaped autonomous implement carrier. It's been to more than a few farm shows over the last few years. DOT was originally created by Regina-based Seedmaster, a company that had never before created a self-propelled machine, so it took many industry observers by surprise when DOT debuted. DOT started out as the brainchild of company founder and president Norbert Bojo. Eventually, a spin-off company, DOT Technologies, was created to further develop and market it. A few machines were sold to producers, but just those in the Regina area, so company technicians could monitor them and provide any early technical support. To operate them, a grower must program field boundaries into DOT's operating system. Then the machine can go to work entirely on its own, but only when it's located within those programmed boundaries. Today, DOT technology has been purchased by the well-known technology company Raven, and it's now one of 2 autonomous projects that firm is pursuing. The second is Raven's AutoCart, which will allow a driverless tractor to pull a grain cart in the field at harvest. AutoCart is basically an aftermarket package designed to be installed in any tractor, and Raven's website claims that installation is just a simple process. The system can be set up to program the tractor to pull a cart to a designated staging location, and even team with a combine to allow for on-the-go unloading. That on-the-go unloading feature sounds very similar to John Deere's Machine Sync, which was introduced several years ago, except Deere does not market it as a fully autonomous system. While Raven is now accepting pre-orders for the AutoCart system, which it says will be available to head into fields this coming harvest season, it has temporarily paused retail sales of DOT, according to a company spokesperson. Instead, the company is looking for what it calls validation partnerships as it continues to refine and test DOT. The company said it hopes to have a much larger fleet of DOTs working in fields this season. Currently, the DOT Power Platform, as it's now known, is capable of working with 3 different implements. Raven is inviting other manufacturers to work with it and create even more compatible implements that can expand DOT's range of use. The advent of entirely new and different field machines like DOT begs the question: is this the start of manufacturers needing to modify implement designs to work with an entirely new group of power units, rather than the conventional style of tractor that's been around since the early 1900s? Or will an implement and power unit be primarily one single machine, like in Xaver? If previous introductions are any indication, there may be a pretty wide variety of autonomous machine styles on the market in the coming years. DOT and Xaver represent completely new concepts, but other manufacturers have focused on sticking with a more conventional tractor design. For example, take a look at what the CNH companies introduced with their concept autonomous tractors under the Case IH and New Holland brands back in 2016 at the Farm Progress Show in the United States. The autonomous Case IH Magnum appeared without a cab, but it's still designed to work with more conventional implement. The New Holland version, which debuted at the same time using basically the same technology, is a conventional tractor with the autonomous features of the Magnum built into it, so it can form a dual-purpose role, function as a conventional tractor or a completely autonomous machine. The autonomous concept power unit that John Deere debuted at Agritechnica in 2019 is also designed to work with conventional implements, but it doesn't look very much like a regular tractor. Of course, neither the CNH nor Deere concept machines have yet been made available to the public, but it's a good bet some version of them will appear at some point in the coming years. So will autonomous machines dominate the industry entirely in the future, or will there be a blend of equipment on offer? Some designed to work on their own, and some that continue to look much like equipment does today. And how much influence will autonomy have on future equipment design? I put those questions to John Deere's Margot Asherle.
I imagine you still see in the foreseeable future kind of two levels of technology. Like Deere has the, at least in the utility segment, more basic tractor designs, synchro transmissions rather than CVT or IVT as Deere calls it. Do you sort of see that two market area continuing where one segment will want a lot of autonomy and autonomous type features where another segment might continue to just want more basic dumb iron, if you will?
Yeah, that's a really great question. I think every customer, I have never talked to two customers that are exactly the same in terms of what they need on their operation. And I do think, Deere is going to continue to make sure that we can support all of our customers' operations as they grow, change. And they're going to be the ultimate feedback loop for us in terms of what will work on their farm and, what levels are needed. And so I can't speak to maybe where autonomy will go necessarily on those levels exactly, but I will say we'll respond to the market and our customers as we have always done with all levels of technology that we've introduced in the same way for autonomy. Is just what's needed for those customers and how can we best serve them.
A lot of different manufacturers have approached autonomy in a lot of different ways in terms of overall machine design. We see AGCO with Xaver, which is a tiny little machine. Deere's module at AgriTechnica. There's a world of difference between those kinds of machines. I would assume then in the future, really, technology is going to be driving machine design to an even larger extent for manufacturers. Would you agree with that?
I do think that there will be some influence there. I do think, though, that the way that we've approached autonomy is, again, to look at a customer's farm and the problems that we're solving, and let that be the driver, right? The one thing I love about Deere and working for Deere is that we're really not a technology company looking for a problem. We have a farming problem that's looking for technology, and so that is, I love that about Deere, and I love that about our approach, and especially in this space where the world, the possibilities are endless here with autonomy, but the real driver of what we're doing is to solve problems using this advanced technology through autonomy, and we're going to let that drive the decisions. We've experimented for like as you said earlier, almost a decade here. We're trying to find that balance between what can we do to solve problems now for customers, and then where does that go in the future? We'll continue to look at that. We'll look at all angles, but it'll be the customer solution that drives the machine form.
Autonomous machine development is great. Smart machines that we already have running in the field is great. Data collection is great. But is the infrastructure in place in rural Canada and many other places around the world to handle the transfer of that kind of data? Is the system in place that can help us control autonomous machines when they come to our fields and start working? I put those questions to both Margot and Matt. Here's what they had to say.
With the limited availability of broadband in a lot of rural areas of North America, has that been kind of a hold up to autonomous development, do you think?
I don't think it's necessarily hold up to the development. There's certainly limited, it limits some of the technology you can introduce and some of that connectivity, but it doesn't necessarily stop it. I think we've got, we've actually tackled this one and started looking into solutions that, more localized solutions for real rural areas. Increased connectivity will always help. I think it will help. It will help farmers in general across their entire fleet, and therefore autonomy as well. But it's certainly something that over time, as we've gotten better, it's one of those technology capabilities that certainly enables more, right? More faster. So it really depends on the task, with autonomy. But I wouldn't say that, any place that doesn't have full connectivity could not do autonomy. We've certainly looked at other options there. It's just a matter of whether or not they really fit on the farm, and are they reasonable for our farmers?
One of the complaints you're no doubt aware of in the rural areas here in North America and even in Europe as well is the lack of really good quality broadband. Do you see that as a limiting factor in any way, or is that something that really needs to be overcome before we can really take advantage of these new technologies?
It's always a limiting factor because these types of systems do require a certain level of connectivity, whether that be typical telematics connectivity where you're sending messages, prescriptions, orders, all these things to and from a piece of machinery. But also from a GPS and positioning standpoint, that connectivity is also required to be able to guide the machine through the field and allow it to perform its tasks. But I think as we look forward, more and more networks are showing up on farms, whether they be mesh networks installed by the farm itself, or we see some of these rural networks improve. I think that we'll see a significant improvement in the connectivity, and we'll see an improvement in the usage of these technologies on the farm, whether they be on a robot or in a current machine form factor. So I see those things improving, and initiatives like the improving rural broadband, things like that, are only going to contribute.
Well, there you have it. That's a look at a lot of what's going on in autonomous machine development in agriculture here in North America right now. Of course, there's a lot we haven't even touched on because there's a lot going on. I mean, Yanmar's already got a commercial tractor in production in Japan. In France, there's a company that's producing a specialized row crop robot. There's a lot. But this is basically what's happening here in North America. I hope you found it interesting and informative. And you can bet your boots there's a lot more going to be happening in the coming years. It's not a question of if we see autonomy, but when. Now, while we touched on agriculture, it's not the only sector that's seeing autonomous R&D happening. And I'm going to leave you with this one segment. Nothing to do with agriculture, although developments in any sector, on-road or off, will benefit all autonomous machine and vehicle development everywhere. But I think you'll find this one a little bit interesting. And, well, I don't know quite how to introduce it except to pull a phrase from Monty Python. And now, for something completely different. Goodbye. I'll leave you with this clip. Thank you for watching.
Well, for a long time now, we've been talking about autonomous machine operation in agriculture, where no operator is required. And we're starting to see the beginning of some commercialization of machines that are capable of it. But the on-road vehicle sector is still some way away from any widespread adoption of that technology. To help drive advancement in that area, the Indianapolis Motor Speedway is holding an event in October to encourage further development of on-road autonomy. So in October, the Speedway will host the first ever autonomous race. No drivers allowed, just 30 cars, all the same Dallara, like you've been looking at just now, competing with each other over 20 laps and hitting 240 miles per hour, all in the hopes of taking home a $1 million grand prize. All 30 Dallaras will be exactly the same, except for the software controlling them. So the competition isn't about horsepower, it's about computing power. And any advances in artificial intelligence technology that originate from this competition will no doubt find their way into ag equipment as well.
The Indianapolis Motor Speedway was established over 110 years ago to test new technologies.
And now self-driving cars are the next grand challenge in automotive technology. But we're still a ways away from having the autonomous vehicle that can drive anywhere and everywhere. We knew that there was a major leap that had to be taken. What better way to do that than a high-speed race at the most famous racetrack in the world?
The Indy Autonomous Challenge, it's unlike any other challenge.
30 teams from around the world, 20 laps, $1 million grand prize.
Our cars here at the Indianapolis Motor Speedway touch 240 miles an hour.
The minute that car is on the track, it has to control itself entirely.
It's racing, but in a futuristic way.
We've known for years that prize competitions can drive innovation.
Competitions are great places to do this because once you get competitive, you most likely will stop sleeping to make sure you win.
The DARPA Grand Challenge led to tremendous advancements in the industry. Sebastian Thrun, who won that DARPA Grand Challenge, said, you know, you've got to create some type of autonomous vehicle competition that would bring back the excitement of the DARPA Grand Challenge. The real challenge is the software. How do you take the information that's coming in from these sensors, compute it, and make decisions that are typically made by a human? We had more than 30 teams coming from 14 US states and representing 11 countries sign up.
University students looked at this problem with fresh new eyes.
We are certain that the future of our racing is going to involve drivers and cars. But if we can go 240 miles an hour and keep cars from colliding, then surely we can make highway traffic safer.
It's all of these universities from around the world with the next generation of the brightest minds, and some of them are going to look back and say it started at the Indianapolis Motor Speedway in the Indy Autonomous Challenge.